Okay, for this video, I want you to check all your work and then write down the 5 words to show me that you listen. But here we go. True or false? Looking at this first problem, what I'm trying to show you, this $4 right here, that is the cost to get in for the county fair. If I want the cost to get in for the state fair, that's this number right here. So again, it costs $2 to get into the state fair. It costs $4 to get into the county fair. The other numbers you need come from this column right here. Adding by 3. That adding by 3 over this 1 makes that the price per ride. It is $3 for every 1 ride. Now you have enough to answer all of these. First one, it cost $5 per ride. It looks like that's 1 for 5, but don't fall for that trap. It's really $3 per ride. So this one is false because it's not $5 per 1 ride. It's $3, and it looks like it's 5. All right, it costs $3 more to get into the county than the state. And if I have 4 and 2, that's only $2 more. That's not $3 more. So this one would also be false. And then the last one, it says 2 rides. For the county fair, 2 rides cost $8. For the table, 2 rides cost $8. So is it the same amount for 2 rides? That would be true for that one. All right, moving on. For this problem right here, all you had to do was write the equation in slope-intercept form. This number right here is my y-intercept, 1, 2, 3, 4, 5. That 5 number goes right here where B is. My next number comes from my slope. If I look, this is going over 1, but since it's going down 2, that's -2. That slope, which is -2 over 1, which is -2, that number goes right here where that M is. That is your slope. So if I write this equation with that slope and y-intercept, it's y equals -2x, that number goes in front of x, plus that 5. There's the equation in slope-intercept form, -2x plus 5. Here we go. Next problem. First word is blue. Thank you for listening, blue. All right, this guy right here, equivalent slopes. It looks like I'm going for AC. I'm going over 5, but going down 3. If I write that the right way, the slope for AC is -3 over 5. If I do that for the big triangle, looks like I'm going right 20, but then going down 12. So if I write that, that gives me the same equivalent slope. Different numbers, but the same value. And it says, how do they compare? They have equivalent. Write this. Slopes. They have the same value. Make sure you're writing it in a complete sentence with capital letters and then a period at the end of each sentence. How do they compare? The slopes are equivalent. They have the same value, which is -0.6. But again, don't worry about giving me that value. Just find the ratios. All right, next problem, number 4. For this guy, again, what you're looking for is no solution, parallel lines. That's parallel. If I had a one solution, intersecting. If I had infinite solution, those would be 2 overlapping lines. So right there. But this one, no solution, parallel lines, never touch. All right, moving on. This guy right here. again, solving by graphing. We did this in class. So this one, I'm going to take away x on both sides, and that gives me the red equation, y equals negative x, or negative 1x minus 1. If I solve this one in blue, take away 3x right here, take away 3x right here, those go away. Make sure to bring down negative y, and that gives me negative 3x plus 5, and then right there, the opposite times in by this negative 1, I'm going to divide everything by negative 1, which makes this y positive now, and gives me y equals positive 3x minus 5. That's going to be the equation for the blue one. So here I go. Starting at negative 1 on the y-axis, and then from there, looking at that number in front of x, which is negative 1, made into a fraction, negative 1 over 1. So from that starting point, right 1, down 1, right 1, down 1. Be able to stair step the opposite direction. Draw your line nice and straight, using a straight edge if needed. All right, my line in blue starting at negative 5. 1, 2, 3, 4, 5. And then this one, looking at that number in front of x, 3, made into a fraction, 3 over 1. Right 1, up 3. Right 1, up 3. Draw the line through those. And then look and see where those lines come together. That point right there looks like I'm going over 1 for x, down 2 for y. That is the solution point. That is the answer. All right, moving on. This guy right here, solving by elimination. I'm going to times this whole top row by negative 1, and I'm going to distribute that negative 1 all the way through and take the time to rewrite it. So I have negative 3x minus 2y equals negative 4. On the bottom, I have 5x plus 2y equals the 12. And when I add those up, that gives me these canceling because they're opposites. Gives me positive 2x equals 8. And then right there, I'm going to divide both sides by 2. And that gives me half of my coordinate, x equals 4. That is half of my answer. Now to find that other piece, take that 4, plug it into any of these equations for x. Doesn't matter, top one, bottom one. I'm going to use the top one just because. So I'm going to put in that 4 right here into that top one. It's going to give me 12. And then right there, I'm going to subtract 12 on both sides of my equation. That's going to give me a negative. That gives me 2y equals negative 8. And then right there, I'm going to divide everything by 2, which gives me y equals negative 4. I'm going to put that number right here. All right, moving on. Next word is dog. Thanks for listening, dog. All right, this one, I can see that it's not a no solution. This one's no good. This one's no good. Only this point right here, negative 2, 5. And then choose a bad one. I'm going to choose D to be the bad one. I know D is a bad choice. Because infinite solution lines overlap. This graph shows one touch. So again, infinite, they're touching everywhere along the lines. I know D is wrong because infinite would be overlapping lines. This graph shows lines touching once, intersecting. All right, moving on. Number 8, This guy right here, the only one with 2 arrows shooting out of it is this input one right here. This is the bad one. All the other ones do not have 2 arrows shooting out of an input number. They all have single arrows shooting out of those input numbers. That makes those functions. Only this one has 2 arrows shooting out of that 3. Cannot have that. That would be like me writing the coordinate 3, 2, and then 3, 3. Cannot have that. Can't have the same x coordinate spit out 2 different y coordinates. All right, moving on. Number 9. For this guy, which bus is faster? Bus number 1, 48, and then I could see this is 50, and then that dot is just above the 50 line. So how do I know which bus is faster? Bus number 2. How do I know? I know because bus number 1 is 48 miles per hour and bus 2 shows above 50 miles per hour. So that's how I know. Graph number 2, bus 2 shows above 50 miles per hour. Bus 1 is below. So I know bus 2 is faster because anything above 50, 51, 50 is bigger than 48. All right, moving on. Number 10, this one right here, comparing. So for a graph, I connect a couple dots on that line, and then going over, that is my run. This is going over 3. Then I can see it's going up 2. So if I write that, that's a slope of 2/3. If I look at this guy, this one is going up by 3s. That is the table's run. And then I can see on the side here going up by 2. That is the table's rise. And how do they compare? They are equal. They have the same exact slopes. They're not even equivalent. Equivalent would be something like 4/6. Those are equivalent because they have different numbers but the same value. But these two, since these are exactly the same, we call them equal. They have equal slopes. All right, moving on. This one has a slope of 2/5. This graph, if I look at it, looks like it's going right 1, 2, 3, 4, 5, up 3. So if I write that slope, that is 3/5, and I can see 3/5 is faster. Graph has a steeper slope, or has a bigger slope, a bigger rate of change. All right, moving on. Number 12, this guy right here. 12, for a y equals mx plus b, it has to be a straight line, either a positive slope or a negative slope line or something straight, or it's got to be a straight line. The only one that shows a straight line is this one right here. These guys are not showing straight lines. These equations keep adding the same amount each time, straight line. All right, moving on. Number 13, this one, what does that 4 mean for this context? Cost and hours. This means it will cost $4 each hour to rent a canoe. That's what that means. That $4, that's the slope. That is $4 per hour. $4 for every 1 hour you're renting. That's how much you're spending on a canoe. All right, 14. This guy right here, you had to find the one that was going uphill for 5 seconds, which is this guy right here going uphill for just one box 5, and then going downhill for 10 seconds, and then flat straight for another 10, and then going down 15 seconds, going down for 15. So that makes this one match exactly. Where the other ones go astray are this one right here. This one is going up by 10, so I know that one's bad right away. This one over here is only going down 5 when it should be going down 10 seconds. And then I think this one has the last bit only go down 10 instead of 15. So trying to show you where those other ones were close, but not quite. Next word is black. All right, this one right here. What is the best choice? Cheetah running faster at 55 seconds. So 55 seconds, it's running about 20 miles per hour. At 15 seconds, it's running 30. So that is a false statement. Cheetah spent longer increasing than decreasing. Let's take a look. So it increased here for 5, 10, 15, 20, 25 seconds. It was increasing its speed, and then looks like it was decreasing its speed for only 15. So that is true. The amount of time increasing was longer than decreasing. This last one is false because it says increase speed for 20 seconds and it's 25. So that one's false. And then cheetah's speed remains constant for the last 15 seconds. Remember, a constant speed would be straight like that, but that's not constant speed. That's slowing down. So that last one is false as well. All right, moving on. Number 16. For this one, if it's going uphill, clearly positive correlation, positive slope, increasing, things going up. If it's going down from left to right, that is clearly negative correlation, decreasing, going down. This guy, if it's curvy like this, that would be none or no correlation. I don't know if this data is going up or going down. I know the positive one is going up, the negative one going down, but I do not know anything about this no correlation one. And then the last one, last two. Number 19, which line best fits through this data? And you can see the only line that goes through the heart of the data is line C. The other ones are not the best fit. Next word is surf. Surf. And then this last one here, number 20. For this guy, I need to draw this line. I need to move it up. If I move this line up, it will go right through the heart of that data. So that's why line should be adjusted higher. That is true. I need to move it up. I do not need to move it down, though. That would be false. That would be if my original line was drawn too high, I need to bring it down, but that's not the case. And then, of course, if the line was right through that data in the beginning, that would be a true line of fit or best line of fit, but this one is not. So that one is false. Last word is wave. Wave. Thanks for listening. Show me this work. Please don't share those words. I'll give you those 500 points you deserve. Good job.